Hi, my name is Sakthesh Ravanan, and this is my digital assignment 2 video presentation for the course Blockchain and Cryptocurrency Technology. So, my topic is to give a video presentation on transaction structure in a blockchain scenario. So, basically, I'll start with a small explanation on what a transaction is. So basically, a transaction is simply an exchange of value between two parties. So in context of a blockchain, a transaction is a record of an exchange. So if there are two entities, they are sharing a value. They are sending a piece of Bitcoin from person A is sending a piece of Bitcoin to person B. So a proof of this exchange is a transaction. So transactions are the building blocks of the blockchain, and enable the transfer of cryptocurrencies like Bitcoin from one user to the other. So yeah, what does transaction consist of? So if Alice wants to go to a movie, for example, let's take it as a scenario. So to ensure this transaction in context of a blockchain, what does it have, and what is it supposed to contain, so that we can describe this whole exchange? So for that, a transaction is supposed to have a set of inputs, outputs, and a way to verify these input and output, so signature, and then incentive for a miner to validate this. So a transaction fees. These four are the important key parts of a transaction. And to understand the structure of a transaction in blockchain, so therefore it's important so that we need to understand the concept of input, output, and this transaction fee in context of a blockchain. So yeah, for example, if Alice wants to watch a movie, and she sends 1 Bitcoin to a movie vendor. In this scenario, Alice Bitcoin holdings are the input. The address of the public address of the movie vendor, the ticket vendor, I mean, is going to be our output. Then the transaction, when it gets completed, it will be broadcasted to the network, where our miner will come and will be incentivized to verify it and add it to the blockchain ledger. So here is a way to showcase a simple, what do you say, a diagrammatical way to represent our, a diagrammatical way to represent the same process. So a node is going to raise a request, and that request is going to be made as a block. So here there won't be only one transaction, there will be many transactions combined together, will be made into a block. So this block will be broadcasted to all the nodes of the network. And once broadcasted, this transaction will be validated, and once validated, it will be added to the existing blockchain, which will signify the completion of a transaction. So yes, now let's come back to the transaction fees. So because blockchain transaction requires this validation requires computational load, that's why we are going to make sure that the one who's going to validate this blocks also get something in return. And to do that, that's how we are going to pay a transaction fees to the miner who is validating these blocks. So the user must pay a fee to incentivize the nodes on the network to process their transaction. And the size of a fee will be determined by the sender and can vary depending on the level of the network. So the next concept would be, now talk about this transaction in context of more of a data structure. Rather than saying an input or an output, a scenario or entity A named Alice, we're going to talk about the variables used in the scripts or how they actually are implemented. Okay, so this is how a transaction as a data structure is implemented for blockchain. Now, as you can see here, here are the fields required to describe a transaction data structure. So the key ones are, as I said, an input counter, and inputs represent what are the inputs address are. output and output counters similarly represents the receiver side, or the public address of a receiver, that is output. The log time is another variable which is going to add an constraint to this transaction. Okay, so now I'm going to talk about something other than an input output transaction fee, something called as an UTXO. So an UTXO is like an unclaimed transaction output. It is going to represent, it's both a transaction and a coin. So let's say Alice has sent Bob 1 Bitcoin. Now, this cryptocurrency, that is this 1 Bitcoin, hasn't changed its location. Rather, what we're saying is that node, this 1 Bitcoin has come from another unclaimed transaction output. And from that, we are generating another unclaimed transaction output, which Bob can use anytime he wants. So that is how an unclaimed transaction output works, and using which we are going to say what is an input and what is the output. Okay, so here is a way to formally describe an unclaimed transaction output. So when a transaction is created, it takes one or more unspent outputs from previous transaction as inputs, and then creates some one or more new outputs with new ownership information and unknowns. And this and this each input reference a previously unspent output, also known as unspent transaction output. Okay, so I'll move on to the individual part. So I already explained that the components of a transaction as a data structure consists of inputs, outputs, and transaction fee. Now I will explain how it works as a data structure part. So let's start with an output of transaction. So yeah, as I mentioned, UTXO, an unclaimed transaction output. Generally, an output is going to be like how do I say it? Uh, so every Bitcoin transaction is supposed to create an output, and it will be stored along with the transaction in the Bitcoin ledger. So the address of this block of output transaction data structure will be present in our earlier in this field of output. So yeah, since we have this data structure, what it's going to say is how much Bitcoin is existing with this UTXO. The second one would be the constraint, a script defining the conditions that need to be spent to spend this output. So these two will be the only part of the output data structure, but they they will be used as they can be used by the owner anytime they want. So now let's talk about the input of the transaction. So I did mention that an output of transaction can be used by any time, by the use owner anytime this person wants. So this, for a transaction, input transaction will also be an output of some other transaction. That's why we have an input transaction as another UTXO. So yes, an input transaction consists of these following fields. Here, a transaction hash will be pointing to an UTXO that is going to be spent now. So if Alice is going to send to Bob, Alice will be having an unclaimed transaction output from previous transaction that Alice currently owns. And if Alice wants to send some amount of Bitcoin to Bob, she's going to use this UTXO as an input. Then she's going to have a script that mentions a condition as an unlocking script. And so that this will be added along with the transaction that's going to be sent, which will in turn create another UTXO, which will be belonging to the Bob. So now we'll come to the final part of a transaction fee. So I have explained about two small concepts of input transaction, output transaction, and how these two are going together with transaction. And when they are made into a block and broadcasted to the network, as I said, a miner is going to validate it by checking the signatures present in them using a computational loop. So how are we going to pay this miner, and how is this data structure? Is there any data structure for it? So for that, the answer is no. We are not going to create a separate data structure for this specific part that is paying the miner. But instead, what we are going to have is that whatever is the difference between input and the output, that is the incentive of the miner. That is, if the input is going to be of the value of 0.015 Bitcoin and the output is 0.010 Bitcoin. So the miner's incentive is going to be 0.005 Bitcoins. So we are not going to represent this as a separate data structure, but rather we are going to mention it together in terms of the existing input and output data structure. So yes, that's how we are going to explain these things. And apart from that, yes, so this is how a transaction data structure exists in a blockchain-based network. So yes, thank you for listening, and yeah, thank you for listening to this short introduction.